All right. It's a great pleasure. So first of all, I'm Sylvia Heubach. I'm a professor in the math department at Cal State LA. And it is my great pleasure to introduce my colleague, Jie Zhong, to be the second keynote speaker at this Pi Day at PCC. Dr. Zhong's research area is in the theory of probability and its applications, and he has a background in financial math and data science. He joined our faculty in 2018 and since has been very active in working with students, primarily through a PIC grant. A PIC grant is a grant to prepare students for industrial careers. It's given by the Math Association of America. His most recent project with his students was in collaboration with the data team of the city of Los Angeles, and his students developed an interactive visualization on crime data trends. This tool also provides very important scientific analysis for local neighborhoods. Dr. Zhong received his PhD from the University of Southern California, which is also my alma mater, in 2013. And after he finished his degree, he traveled the world. He had visiting positions and postdoc appointments at universities in Japan, France, China, and Florida. He also spent a semester at the Mathematical Sciences Research Institute in Berkeley, and just before coming to Cal State LA, he had a 2-year position at the University of Rochester in New York. Without further ado, let's welcome Dr. Zhong.
Thank you, Sylvia. Thank you, everyone here. And first of all, and of course, and to thank Yuchen and Daphne, and of course the organizers of the Pi Day event to have me here. And I'm so honored actually to share my experiences on this title, How to Land a Job in Data Science. And of course, and I'm fortunate to be here to learn from the experts actually from industry, like from the panelists in pre-session, okay? And so this presentation actually is totally based on my own experiences. And of course, together with experiences that I mentor my students in industry and also in the academic. And this actually could be developed to a series of workshops related to how to find a job. And so I will try my best to cover as many as important points here so that can learn from each other. So as you can see, I'm here also want to learn more in this field, which means that the data science basically is a fast developing and evolving discipline, which means that you're going to learn the technique that's going to be outdated maybe out of a year or maybe a month even. So that any comments or suggestions, especially the suggestions that here I will definitely to appreciate. And so even the main point is how to land a job or say find a job in this field. There are, I think, many of you are familiar, but there's few maybe new to this discipline or career. So why not I give you very briefly what is data science, at least in my perspective. So simply put, data science is nothing but using the scientific technology and language to analyze data so that we make conclusions using human beings' language interpretations. In most of the previous maybe knowledge that you learned about data science involving two parts, but I have to emphasize in nowadays daily work as a data analyst and even data scientist. The third component, human interpretation, is more valuable. And you can see as the technology advances, a lot of things can be automatic, even the data and the science part. But human beings, because we are so diverse, so we can interpret and provide valuable insights, even given the same data set. So keep in mind, actually, the third component is the thing that we can beat, actually, the machines. But why data science here, right? And we can talk about different career paths. But data science basically is everywhere. And we can think about a very easy and simple example. Some of students actually have to think about how much work I need to put into one course so that I can get desired GPA. So natural question is that more time or more hours per week I make into this discipline or course, can I get a better GPA? So this is definitely a simple but a solid data science question. That you have data, numerical data, number of hours work, and your GPA, and the output would understand is there any relationship between the two. And of course, the data science not only limited to such a simple task, and the most basically the complex system, let's say the weather system, contains thousands of parameters. So they also use the data science techniques and the discipline scale. So that's why the job, this career is so high demand, and you can even easily try to Google the data scientist, data analyst job in Google search. You can find the millions of them, no doubt. Okay, that's because it can be applied in different various disciplines: medical research, physics, computer science, engineering, finance, of course. Okay? And so I would consider actually the data science as a new literacy, as disciplines, even as an undergraduate student, that you basically inevitably going to touch or experience one or another perspectives of data science. And you're going to be benefited from not only that as a career plan, but also your personal finance, for example, personal issues using data science technology. So in this presentation, actually, I'm going to talk about several pieces. Start from the knowledge preparations, so that what kind of technicals or skills you need to start with. And of course, the talk is mainly targeted to the students or the audience that you're new to this field. And we are going to talk about the entry-level job. Once you have the knowledge you learn from the school's work, we need to put into practice. Okay? And you can see even from the panelists mentioned, if you only show your schoolwork, your lack of the ability to solve the practical problems. Okay? Because usually the schoolwork will be clean to you. I give you a problem as an instructor, most of the time the problem is definitely solvable. But in the practical, not necessary. Most of the problem cannot be solved in general, so how can you still find the solution to complete the task? The first two components I would consider as the hardware skills you can have. So you show your muscles. But then you need the stage. How do you do that? Traditionally, you will, of course, after or maybe close to graduation, you create your own resume or CVs. 1 page or 2 pages at the most, with GPA, education experiences, maybe some internship experiences on 1 or 2 pages of paper. It's too cold. And sometimes, actually, you submit it to hundreds of companies, you just wait. This is the old-fashioned way to find a job. Okay? Think about your YouTubers. your Instagram influencers, how you brand yourself is a new way, or in other way, is a more proactive way to find a job. And the last, of course not the least, is that you need to be more talkative to communicate with other people. Because in the end, you work with people on the tasks and projects. So we are also talking about how to networking. Technical skills start from the textbook or, say, the courses, right? But most of the time, as non-mathematical major students, if you're interested in data science, you would ask, do math needed here? Yes, of course. Okay? Not even because I'm a math professor, try to promote this major, but you think about, we are doing science. Data science, the key is try to formulate the practical problem so that you can rigorously state it. And also important, you can convert it into the code so that you can communicate with machines. So this ability actually needs training in mathematics. Okay? But more practically, you will ask another question. I'm not a math major, so how much actually do I need to understand mathematics? In what kind of depth? Okay? So then you have to think about your goals and your problems actually you want to solve. But in general, there's some rules here, for data science at least. You think about data, first of all, is the data is our object to deal with. That presented in different ways. And mathematically speaking, presented in the vectors, matrices, and even tensors, if you are talking about computer vision. So that, yes, linear algebra, of course, is a must. So how to understand the construction of the data is important. Another part of the knowledge in mathematics is the randomness. Okay? You can see we have so many of data. When you analyze a model, sometimes you cannot access to the generation or, say, the population of data. So you need to do some smart move, let's say sampling. So then you have randomness intrinsically within the data. Then you need knowledge from probability and stats. And also, even nowadays, there are a lot of deterministic problems. They try to use random algorithms to solve them. For example, the AlphaGo algorithm, even back into 2016, that DeepMind company basically proposed a new algorithm, okay, so that you can beat human beings for the Go game. This is the first time that actually the machines can compete with the human beings in such efficient way. But they use the random ideas here. And another thing, why calculus is always mentioned in different disciplines, and of course here in data science. One thing you can think about, if you want to predict a certain value using the data, so that you want to evaluate the model you select. So you have to measure, for example, the difference between your prediction and the true value. So your goal would be an optimization problem which try to minimize the difference of your prediction and true value. Okay? So this is actually the knowledge you can learn, or say you have touched before in Calculus 1, that you find the derivatives of a smooth function. In this case, would be the L2 function. Okay? So that you want to make sure your derivative is 0. That's the critical point we call it. So that you make it 0, find the candidates for the extremes. This is very simple. You think about this very simple idea that we used, even we learned in Calculus 1, but I can tell you, almost every single algorithms, models, in machine learning and data science. They apply this one for the parameter tuning. Okay? So even you can search the gradient descent as one of the first and powerful algorithms to find the minimum. So again, out of the, or say, driven by your goals and problems, so these 3 or 4 courses are the fundamentals. So fortunately, as a math major, I think this is something as required. But for non-math major, what do you want to do? What can you do about it? And have you to take the degree in mathematics? Not necessary, but you still need to understand certain criteria. Okay? So here I provide you a very famous example, actually. So the CS229 is the number of a course for the Introduction to Machine Learning offered by Stanford, initiated by Professor Andrew Ng. This is one of the most popular machine learning courses, okay, around the world, period. Okay. Actually, I recommend this one to all of my research students to start with. And so in their website, it is open, and you can find YouTube videos and the schedule of the material of the course and everything there. Okay? And you can see under their class notes, there are at least 2 review notes for what kind of mathematics you need. For example, one of the notes named matrix calculus. Basically, it's combined linear algebra and calculus together. And another one is a review of probability theory. So for my students, I usually encourage them to look through at least the concepts, definitions there, or notations, for example, if you're familiar with that. If you're so unfamiliar with anything mentioned, means that you probably need a course on that topic. So this is how you sense how far away actually the reality between the reality requirement and yourself. Again, there's no actually end, or say never enough to learn mathematics. Okay? But try to think about you learn, especially after the basics, the 3 or 4 courses I mentioned, there are more actually interesting topics that may be required for your specific job. So then try to learn starting from there. Because the only thing is that the interests driven, okay, drives your motivation so that you can learn better. So that's the math part, okay? What you can see when I talk about the machine learning, actually even in the previous slides, related to data science. But what is the relationship between the two? The data science is a whole package that in the middle, there is a part that you have to process your data using certain toolbox. Okay, nowadays, people so-called machine learning. It's try to use machines, okay, and run the algorithms to generate results. Machine learning is not new, okay? It's not new. And you can, if you read literature back into 50s, 60s, 70s even, okay? So there are traditional models we have known long before, okay? I mean, this boom of the AI or machine learning technology here. But also there are state-of-the-art technology, neural networks, and deep learning. This is another thing that my students ask me frequently, that where should I start? I should start with the state-of-the-art technology, deep learning directly, or have to go back to learn the traditional models? Okay? The short answer is both. Short answer is both. Because you can see, even in the industry, people use neural networks a lot to deal with the large data set. But not for every single problem, especially if you target data science job. Because for some jobs, you have very limited data. That the data actually not require so much power, but more into the specific models. So why not go back to even the simplest one? For example, in finance, in hedge fund company, if you're a trader, especially the high-frequency trader, you don't have time to actually use the deep learning to spend of thousands of dollars on energy or GPUs to train your model to get a result, then you train, because it's a millisecond. So within that millisecond, sometimes people, experienced trader, will use the simplest model or algorithms to get the right action, because the accuracy sometimes is not that important in terms of the speed. So just to give you extreme example, when you're doing the data science, don't think about every time you're going to have a very complicated model to do the problem. So sometimes the simplest one will give you the interpretable results. This is another thing when you talk about traditional models and the deep learning. One of the cons or shortcomings of deep learning is that it's a black box. It's a very complicated structure. You have CNN, you have the GAN, you have the different models that you input your data, feed your data, and you don't know what's going on, then you have output. So it's not easy to interpret, as I mentioned, as a data scientist. Sometimes interpretation is more important because you have to tell people what does the number mean in general. Okay? In terms of how to start with the journey in learning machine learning, right? So again, this is my first choice, okay? From Stanford, open source. But you see, if you look at that two resources I shared, the mathematics there is not easy. You need to take at least 2 or 3 semesters of courses. Or in other words, should I wait another maybe 2 years to study mathematics so that I can involve this maybe fascinating technology, machine learning? No. You always can start as early as you can, as early as you would like to do. So there's another one. There's another one is short like ISLR. It's Introduction to Statistical Learning using R. This is another textbook, very popular, but have low actual requirements compared to another course. But still give you the very interesting but solid introduction to this field to understand the whole pipeline, how to deal with the data using mathematical thinking. Okay, again, if you click on the link, go into the website, you can download the textbook for free, and even there are Python and or maybe some notebooks available. Okay, so here again, all the resources I shared is based on, the usage by my students and myself too. So you talk about the machine learning, so to be algorithms, then you have to somehow think about how to implement it. We are not actually just theorists here. So you need to implement your ideas, which means you have to code. We're not talking about to code as a software engineers, but just to prototype the models, for example, as a data scientist. You still need a certain level of programming skills. It depends on your previous experiences. You can choose actually whichever you like. But in general, nowadays, Python is kind of industry standard. There's another one I mentioned, R, even in the previous textbook, Introduction to Statistical Learning using R. R is another language, but more focused on, let's say, statistics. in some, let's say, the pharmacy company or medical research, they're more interested in the statistical test. So they require you to use Python. And I would say more than 80% of the company. So we prefer Python instead. And Python is so popular because it's open sourced, and you can see there are many open but handy libraries can use, basically designed actually for data science. After you have a basic idea of the language, and you have to write your functions. You have to write your code, make things work. To have a better understanding the data structures and algorithms, actually these are two fundamental courses in computer science department. Okay? But if you're not a computer science major, these two are necessary because a quarter to 1/3 parts of your interview questions come from these two. You have to code actually in front of the interviews. So how to do this, right? And should I get a CS major? And we already have to do something in mathematics, then there's another one, okay? But nowadays, the internet is everything you need, actually, okay? So if you don't have any programming experiences, I'm talking about for some people still interested in this promoting the career, but you never have such experiences. So I would start with this so-called structure and the interpretation of computer programs. This is a classical textbook and also a course from MIT, but in 60s and 70s. Nowadays, UC Berkeley, okay, have this CS61A. This is another open source course, open to everyone. Share the codes and the course materials to everyone. So it's Python version of such a material. There's so many choices actually you learn programming languages, or why I mentioned this one. This is very suitable for data science and machine learning in the sense that we consider all the objects actually as a function. This is also a favorite topic as a mathematician. When you read this book, the whole point is that we enforce you to understand the programming as a function so that you can understand how the computer actually programs on back, okay? And of course, Google, YouTube, or your friends. When I talk to my research students, the first two tools or the abilities I would like them to shop is to shop their search ability using YouTube and Google. But yes, as you see, we have a director from Nevada, and so ChatGPT. I'm not sure how many of you have used. Even when I prepare for these slides, I used ChatGPT. It's amazing, phenomenal, okay? Especially if you want to learn programming. For example, you just type Python, then your goal. I want to write a code to sort. Okay, give you examples, give you codes directly. It's better than Google in the sense that Google gives you a lot of entries. You have to click it, and you have to look at it, then choose the right one. So this automatically just within seconds. Okay? So you have everything. For example, even you don't have everything, what should you do at the same time or after that? We have to put what you have learned into reality to solve a real problem, which means projects. So this is a job that you really want to solve the practical problems. So it means that you have to fill the gap between what you have learned in your schools and what you're supposed to do in the industry, okay? But what is a project in your mind? A project, maybe you think about, oh, I need to build an autonomous car. That's a big, ambitious project, yes. And maybe you want to use some data to create a chat GPT like chatbot. Yes, of course, that's a big project too. But for me, even for students, you have to think about the project is anything that has contents which can contribute values to you and others. Any content can generate values would be a project. So that's basically to broaden your idea about projects so you can start with. Okay? So start with your notes. Will this be a project? Definitely. I will also combine this idea into the branding next time, next few slides, talking about your notes. Which means that you can start your project in the beginning when you start the journey of learning data science, or the mathematics courses, or the machine learning technologies, and even programming. You document your notes digitally. And what do you do next? You publish your notes. In a way, for example, via blogs. I'm talking about finding a job, but what or why this is related to find a job? Or think about if you encounter a problem in your coursework, in your projects. You Google, right? What do? Usually you search keywords. How to do this in this language. And sometimes you have look at entries directly to the blog entries from some people. Then you read. To understand the concepts from other people's perspectives. So you see, the contents actually created add value to you. But also you think about the HRs, the recruiters. They will use the same idea to find people. That, okay, I can see how people can deliver the thoughts they have learned into public. This is very good and very important quality as a candidate for this job. So this is another way to promote your ability, to show what you have learned. And definitely, it's going to benefit yourselves to summarize what you have learned. And start with a project with your enthusiasm and interest. This is the only way you can go a very long journey. Because you can see you have so many things to learn and you have to update your knowledge constantly. Okay? So let's talk about the interest, right? So when I was in University of Rochester, one of my students, she is interested in this field, data science, but she asked me, where should I start? So I asked the question like, what are your hobbies outside of school? Okay, forget about the coursework, what do you want to do? She replied, say, I don't have much hobbies, but I only like to eat. Okay, I like the food. I like try different restaurants. That's my hobbies during the weekends. Could this be related to data science? Of course. Why not? When I talk about the popularity of data science, anything related to data is data science. And for example, Yelp, right? The company and the app in your phone, sometimes you want to search the restaurants nearby. Okay, you use one of the apps, let's say, called Yelp. The group of data scientists and machine learning engineers behind the scene to design so-called the recommendation system. Okay, and also the rank system, for example, for the restaurants. So I ask my students, why not? You learn from there. So try to rank the restaurants you already have tried, okay? And learn what kind of technologies you need to do such a job. So anything, that's why I mentioned related to data, you can think of. as a data science. So try to be creative. But sometimes, again, your goal is too ambitious. I want to build up a recommendation system like Yelp. They have hundreds of people doing this. You're only one. How you start, right? How you start? You start from others without. You build the new things based on the previous experiences. You learn from experts. They also learn their failures, experiences too. And for example, the Kaigo. This is another stop, okay? You need to visit. It's a website. Basically, first of all, try to provide the data to audience so you compete to see the accuracy of a model. But nowadays, it's like a community for all the data scientists enthusiasts. They come together, okay, to solve maybe the same data set problem, but with different ideas. So there are thousands of existing and completed projects. And you can find one similar to your interests. Start from there. And GitHub too. Okay? So GitHub basically, for some of you are not familiar with, is a place to store your codes behind the scene. But nowadays, people use this as projects, repositories. They call it repos or repositories. So this is another place actually recruiters are very into to look at, check out what can you do. They can understand really your project going to be related to the job descriptions or not. So try to build a profile and start build your portfolios using this tool too. So once you consider start with a project, how do you think a project is complete? Okay, so there's no completeness actually. There's no end for a project because you always can improve. But in general, we are talking about a time frame. This is something different from mathematical research. Sometimes we spend years to explore a certain theorem or prove that theorem. But in data science, in technology, you have some timeline. You have deadlines to meet. Okay? But at least as students, I have to consider these three things. Once you finish a project, you try to summarize in the format of slides, posters like this, today's event, and write report, even in a paper format. This is always good to summarize what you have learned. And show people, actually, you have done this, you know all this, what you tried. In a typical interviews procedure, and the hiring manager usually look at your resume to check some projects you have done, so asked what you know about it. So you have to articulate what you have done and the specifics, difficulties you've been through. So if you have this written format, and yes, in the end, you're going to try to publish in a way that other people can access to promote yourself. How to finish, actually, a project? You're not in the industry yet, because there is a position called it project manager. But now, you're on your own. This is a common, actually, issue when you start a project from the real world. Okay? Here is basically kind of a roadmap when you have a data science project. Start from, for example, the data collection, data cleaning, and the feature selection or engineering. Then you have a model selection part, so that then you try to tune your parameters to have higher accuracy. And in the end, you have a validation process so that make sure you can write this reports, slides, and posters, and so forth. happened actually just 1 week ago for my students. There are two groups of students trying to meet some deadline for projects. However, in the end, they failed. Okay? This is very valuable experiences. That one of the projects my students want to do is try to predict the super bloom actually for the California flowers. Okay? So she tried to find some data set. Within actually almost 2 months, she spent more than 2/3 of the time actually just finding the data and clean the data. That's a very common actual mistake you're going to have, because it is not a schoolwork. I give you a clean problem to solve because you can actually solve anyway. But for the real data, it's very messy. You spend hours and hours to make sure the format of the data actually can fit into your model. And so you are not familiar with, and you have so many frustrations here. But don't stop there. Try to move forward, which means I would like you to try to, for example, plan ahead always for any project. That you chunk your timeline into several pieces for these, for example, 6 components. Make sure you can move along. Maybe you have some difficulties. That's fine. You solve the whole procedure. You try to improve it as a cycle. At least before the deadline, you have so-called a complete project. Okay? So this is a very valuable lesson I would like to share with others, with all of you here, so that when you try to finish a project, okay, keep it simple but complete in the very beginning. The first two, again, the components, I would consider the hardware skills, right? So how can you share such abilities and all you have to HRs, the recruiters, the industry? We do it proactively, okay? So first, start with a personal website. Why do I need a personal website? This is the brand. It's yourself here. So that in the website, you can have a CV. You can have a portfolio of projects you have done. You can have the blogs of notes that you documented. Okay? Even you have some experience you want to share, the failure experiences you want to share in that personal website. It's a place to document actually how you grow as a student to a profession. Okay? And this is also important that people can find you as long as they can access to the internet. And this WowCammy is one of the open sourced, okay, that you can use freely to build up the website. Of course, you can choose other choices here. The main point is that try to start now. Why now? Am I supposed to do it maybe after I have a complete resume, I have all the overall GPA, and I have lots of solid projects, and then I can build up my personal website? No. Start immediately. Okay? Even just the name of this website is good. 1 versus 0. This is so important that people can find you. Okay, you don't have the project, that's fine. You can even write down the projects to be done. You propose projects. Okay, you don't have complete resume, at least you have what you have now for the GPAs and for the coursework you have done. We are talking about because some audience will ask, how can I stand out in the job hunting for internships and other things? This is where you stand out. Because other people only have 1 or 2 pages resumes, no other things. Because it's very likely you have the same GPAs, you have the same similar experiences, but you don't have the active way to show to other people. Again, try to think about your YouTuber. right? You work constantly to promote your contents. And also, think about no perfection at all, please. Even for myself, I have this, intention. I want my website to look beautiful. Okay, the fonts and even arrangements of content. Start with something ugly, please. Okay, something plain. The content itself are more important than the outsides. Okay, you can search even some professors or maybe the experts, industrial experts website. Not necessary to be very fancy, but the content-wise is so valuable. And these three are the social media accounts I recommend you have. LinkedIn, of course, right? It is now a professional standard that the HRs will first go to that place to find your profile by searching keywords. And GitHub is a place to store your projects, codes, and Twitter. Why Twitter here? Sometimes, we use Twitter to message. If you're curious, actually, in this field, you can find almost all these experts in AI and machine learning, and even some mathematicians, they have Twitter accounts because that is the fastest way to spread out words of their new discoveries. So this is the way that you can actually share what you have immediately. Okay? And of course, other social medias. There are a lot of data scientists actually create YouTube channels to share their experiences, how to find a job and how to interview. And not just the benefit to, let's try to have more fans or followers. More importantly, benefit themselves, benefit their skills in their own field. Okay? If you have time and you're interested in this, why not combine all your interests together? So the last part, but not the least, right? Networking. Why we're here? We try to learn from each other. Okay? And in the end, again, you have to work with people. You have to talk to people. Okay? So it starts from the teamwork. That when you build up your project, you join other people's team to work together and learn the strengths from others and to share your strengths to others. That's always start point. And sometimes your teammates already find a job. So can be your reference, for example, because he knows much, much better in person how you can deliver a project at the results. Join this or attend the in-person or online events like this. Okay? So not necessarily every piece of information, even my talk here is very helpful to you, but in general, you can have all this, right? You can have different diverse sounds and experiences. Yes, I have to mention this LinkedIn and even Handshake again. These two actually are more formal platforms for students like you. Okay, one like Handshake is more used in the university system. But please try to learn how to make your profile so that we be easily to be found by the recruiters. One thing you can keep in mind, if you're looking for a specific job, try to highlight the keyword from the job description into your LinkedIn or Handshake accounts. That's always the key, okay? The keywords, so that to let people know you have all of this. And conferences, seminars, workshops is always to sharpen your knowledge constantly. Keep up with the fast, let's say, developing technology in this field. And the last, okay, yes, of course. Join this Pi Day at PCC every year, and I very much actually appreciate the opportunity to learn from you too. Okay? So, thanks everyone. Any questions?
Well, thanks very much for such an enlightening and action-packed talk. So we were starting a little late, so we'll have one at most two questions so we don't get too far behind in time. So let's see, who wants to be the first? Hello? Yeah. So who has a question? Okay.
So approaching the industry, approaching the industry, they do have like I guess interactions like let's say interviews, and there are I guess interviewing us and like asking questions, and as an interviewee, what would be like an appropriate question back to our interviewer about data science and I guess knowing the foundation of this?
Oh, that's a good question. That's a good question. That's something that I don't have time to include in my presentation about interview. Okay? So for the interview, basically you can think of they will test you the basic knowledge that I mentioned. Even some probability problems, okay? Some like the brainstorms problems that you need to understand the basics. And I can give you an example. If you are going to interview for example, PhD level engineering job in machine learning, they will ask you how to describe, for example, epsilon data language for continuity for functions. Which means, this is one of the basics you have to understand, at least for mathematics. Okay? And also, in terms of the coding part, so that's why I recommend you to prepare some problems in data structures and algorithms. This is another component of interviewing. And the third would be the practical problem solving. Give you a practical problem and ask you using the idea you have how to solve it. But they are not asking for complete solutions, but actually want to see how you act. Especially some problems, actually, they don't know even the answer. They want you inspire them in a way that you are problem solver.
I think if I understood your question correctly, it was if they ask you, so do you have any questions for us? What would your question to them? Is that what you wanted?
It's like a two-part question about like basically the main point I was trying to get at is like, okay, what is the best way to approach an interview in this kind of industry as well? And I know there's like, I guess, different approaches to try to, I guess, stand out. And there's the part where they like, oh, at the end, do you have questions for us? So that part is also included where it's like, okay.
That could be very general, not necessarily or limited to data science. Once the hiring manager asks what question you have, means that they want to see if you're interested, really interested, enthusiastic about this position. Because if you share some thoughts about concerns even about the company, the job, means you really want the job. So that's one of the, at least one of the answers they expect from you.
Okay, we have one more question. Okay, over there, let me come.
How would you suggest choosing a major for a data science career? Because I know like engineering, there's like different engineering applications. And then
Sorry, can you make it loud? Okay.
So the question was on how should you pick a major if you're interested in data science? There is engineering applications, other majors. Is there sort of a good one to pick, right?
Okay, so first of all, if you can do a math major or minor, I would strongly recommend to do that. Because you can see for the math part, then you're done. You can learn from others. Okay? But if a non-math major, doesn't matter too much, because you have to learn as a whole package. So again, more important thing is that you know your goals and to think about your problem solver. The technology, the knowledge is try to help you to achieve this goal. So you have to have your goal first, then you can pick up the skills that you need and you emphasize. Okay.
May I just say something? I think you picked up on something very important, that there is minors. So you can take one major, but then pick a minor that goes with it. Very often a minor doesn't take a lot of extra courses, and it gives you an edge by saying, I have also some knowledge in this other area. So it's not necessarily a one and all, but you can package two things together.
Yes, and also especially for the STEM disciplines like the computer science, engineering, or physics, chemistry, because you already need a certain level of the calculus and the linear algebra and the probability and stats. So yes, if you can take minor and have an even deeper understanding, so can actually to make your, the study more efficient.
All right, let's give our speaker another round of applause.
Thank you, everyone.
And I think we have one more speaker.